The real reason we don't eat insects, even though they're the best protein. Roughly 1.8 million years ago, in a cave system at Swartkrans, in what is now South Africa, an early hominin picked up a fragment of animal bone, wore it down to a point against stone, and used it to break through the concrete hard wall of a termite mound. We know this happened because in 2001, researchers Lucinda Backwell and Francesco Derico published a microscopic wear analysis of bone tools recovered from that site. The abrasion patterns on the tips were distinct and repeatable. They did not match the wear produced by digging soil or scraping hides. They matched, specifically, the pattern created by forcing a pointed object into the reinforced, cement-like walls of a termite nest. Someone was making tools for one purpose only: extracting insects, nearly 2 million years before anyone planted a crop or penned an animal. That discovery was one data point in a mountain of evidence. In 2018, biological anthropologist Julie Lesnick of Wayne State University published an entire book tracing the archaeological, nutritional, and genetic record of insect eating across the full span of human evolution. Her conclusion was blunt. Entomophagy, the practice of eating insects, is one of the oldest continuous feeding behaviors in the primate lineage. It predates organized hunting of large animals, the controlled use of fire, and our own genus. And it never stopped. Today, an estimated 2 billion people across more than 100 countries eat insects as a routine, unremarkable part of their diet. Close to 2,000 species have been documented as edible. In the markets of Bangkok, the highland kitchens of Oaxaca, the roadside stalls of Kinshasa, insects are bought, sold, seasoned, and eaten with the same casual normalcy that people in London or Chicago reserve for chicken wings. Here is the number that should stop you cold. A kilogram of cricket protein requires roughly 2 kilograms of feed to produce. A kilogram of beef protein requires somewhere around 10 kilograms of feed, depending on the system. That is not a small gap. That is an entire order of magnitude in efficiency, and it is only the beginning of the list. Crickets need a fraction of the water. They need a fraction of the land. They produce a fraction of the greenhouse gas. By nearly every measurable standard of biological efficiency, insects are the best terrestrial protein source available to our species. That was the reality for the overwhelming majority of human history. Then, over a few thousand years, the civilizations that would eventually control global trade, agriculture, and food policy decided collectively that this ancestral food was revolting. Today, there is no insect aisle in a Berlin supermarket, no cricket section in a Chicago grocery store. In most of the Western world, you could walk every aisle of every store in your city and not find a single product marketed as insect food. The science is not ambiguous. The rejection is total. And the story of how that happened, and why it might not last, is stranger than you think. Let's go back further, because the roots of this go deeper than agriculture, deeper than Europe, deeper than humanity itself. In 1960, a young researcher named Jane Goodall was sitting in the forests along the Gombe stream in what was then Tanganyika, present-day Tanzania, watching a chimpanzee she had named David Greybeard do something the scientific establishment at the time considered impossible for a non-human animal. He selected a twig from a nearby shrub, stripped the leaves from it with his fingers, and inserted it carefully into a narrow opening in a termite mound. When he pulled it back out, it was covered in soldier termites clinging to it with their jaws. He ate them off the twig, methodically, then inserted it again, and repeated the process for the better part of an hour. The observation reshaped an entire field, since tool use had long been considered a defining boundary between humans and every other animal. But one implication took decades to be fully appreciated. Chimpanzees share around 98% of our DNA. If they use manufactured tools to harvest insects, the common ancestor we share with them, a creature that lived roughly 6 to 7 million years ago, almost certainly did too. Deliberate insect harvesting has likely been part of the hominid behavioral repertoire longer than upright walking has existed in its modern form. Lesnick's research pushed this further with evidence most people have never heard of. Fossilized human waste, coprolites, recovered from dry cave sites in the American Southwest and dated to roughly 10,000 years ago, contain identifiable fragments of grasshoppers, ants, and beetle larvae. The concentrations are too high and too consistent across samples to be explained as accidental contamination. People were eating insects on purpose, regularly, in quantities large enough to matter for their daily caloric intake. The logic behind this is not mysterious once you think about it. Insects are, gram for gram, among the densest sources of nutrition available in any terrestrial ecosystem. A single termite mound can contain millions of individual insects. Each one is a compact package of protein, fat, and micronutrients. For an early hominin without spears, without fire, without any of the technology required to bring down large game, a termite mound was something extraordinary. A stationary, renewable, calorie-dense food source that did not run and did not fight back. Modern field studies of wild chimpanzees confirm just how significant this contribution can be. Termite fishing provides measurable daily protein for populations across Central Africa. The insects themselves are rich in essential fatty acids, contain iron at levels comparable to red meat, and their exoskeletons are made largely of chitin, a fibrous compound that functions in the gut like dietary fiber, and may even feed beneficial gut bacteria. This was never a fallback food eaten only when nothing better could be found. For millions of years, insects were the protein backbone of our lineage. Here is where the story takes a turn that almost nobody expects, because the modern nutritional science does not just confirm that insects mattered historically. It shows that insects are, by nearly every measurable standard, superior to the protein sources that eventually replaced them. In 2013, the Food and Agriculture Organization of the United Nations published a report called Edible Insects: Future Prospects for Food and Feed Security. It was led by entomologist Arnold van Huys of Wageningen University in the Netherlands. The report pulled together data from hundreds of studies across dozens of countries, and its conclusions were hard to argue with. Crickets contain somewhere between 55 and 70% protein by dry weight. For comparison, raw beef sits around 26% protein by weight, and chicken breast around 31%. Mealworm larvae provide all 9 essential amino acids in proportions comparable to beef and fish. Many edible insect species meet or exceed the amino acid reference standards set by international health bodies for human nutrition. And protein is only the opening argument. Several edible insect species contain higher concentrations of iron, zinc, and B vitamins per gram than conventional livestock. Mopane worms, the caterpillars of the emperor moth, harvested across southern Africa, contain iron levels that dwarf what you'd find in an equivalent weight of beef. Black soldier fly larvae are rich in calcium and lauric acid, a fatty acid with documented antimicrobial properties that is also found, notably, in human breast milk and coconut oil. Then there's the efficiency data, and this is where the gap stops being interesting and starts being staggering. To produce a kilogram of live weight in beef cattle, farmers need roughly 10 kilograms of feed. For pork, the ratio is closer to 5 to 1. For poultry, around 2.5 to 1. For crickets, the ratio drops to somewhere near 1.5 to 2 to 1. A cricket converts feed into body mass several times more efficiently than a cow does. The water numbers are more dramatic still. Producing a kilogram of beef protein requires thousands of liters of water, enough to fill dozens of bathtubs. Producing the same amount of cricket protein requires a small fraction of that. Land tells the same story. Cattle ranching occupies more than a quarter of the planet's ice-free land surface. Cricket farming can be done vertically, in stacked bins, inside a climate-controlled room the size of a suburban garage. And the emissions gap may be the most consequential number of all. Cattle production generates enormous volumes of methane per kilogram of protein produced, a greenhouse gas many times more potent than carbon dioxide over a short time horizon. Crickets produce a small fraction of that. We are not talking about a marginal improvement. We are talking about a reduction measured in multiples, not percentages. Insects can also be raised on waste streams, food scraps, agricultural byproducts, spent grain, turning material that would otherwise rot in a landfill into high-quality protein. They don't require the routine antibiotic use that industrial livestock farming depends on. They don't require growth hormones. Roughly 80% of a cricket's body is edible and digestible. For a cow, that figure is closer to 40%. Insects reach harvest size in 6 to 8 weeks. Cattle take 18 months to 2 years. Every single metric points the same direction. And yet, walk into a supermarket in Chicago, London, Sydney, or Berlin, and there is nothing on the shelf that tells that story. The science could not be clearer. The adoption could not be more absent. To understand why the wealthiest nations on Earth reject the most efficient protein on the planet, you have to understand an emotion that operates faster than conscious thought and overrides rational analysis almost completely. That emotion is disgust. In the 1980s and 1990s, psychologist Paul Rosen at the University of Pennsylvania built much of the modern scientific understanding of disgust as a cultural force. Rosen found something deeply counterintuitive. Disgust is not primarily about taste, and it's not primarily about smell. It's about contamination. A food that triggers genuine disgust doesn't simply fail to appeal. It contaminates everything it touches, at least in the mind of the person experiencing it. Rosen demonstrated this with a now classic experiment. Subjects were shown a glass of fresh juice. A sterilized cockroach, confirmed clean, confirmed harmless, was briefly dipped into the juice and removed. Subjects were told explicitly that both the cockroach and the juice were safe. They understood this, and overwhelmingly, they still refused to drink it. The mere contact between something classified as disgusting and an otherwise fine food rendered the whole glass unacceptable, regardless of any rational assessment of risk. That matters because it shows disgust doesn't run on risk calculation. It runs on symbolic contamination. The cockroach carried no bacteria. It carried meaning, powerful enough to override thirst, hunger, and the conscious knowledge that the drink was safe. Rosen traced the evolutionary roots of disgust to pathogen avoidance. In ancestral environments, long before anyone understood germ theory, organisms that instinctively avoided decaying matter, feces, and unfamiliar biological substances were less likely to ingest something that would kill them. Disgust evolved as a fast, automatic, pre-conscious immune system. You don't need to identify a specific pathogen on a rotting carcass. Your gut reaction makes the decision before your conscious mind even engages. And the decision is always the same: reject, withdraw, do not consume. But here's the detail that changes everything. Disgust is not hardwired to specific foods. It's learned. Infants show essentially no food disgust. Toddlers under 2 will happily put dirt, insects, and anything else that would make an adult recoil directly into their mouths. The specific foods that trigger disgust are absorbed through cultural transmission, typically between ages 4 and 8. As children pick up an unspoken set of rules from their community about what counts as food and what counts as contamination. Sit with that for a second. The Western disgust response to insects is not biological. It is cultural programming installed in early childhood, running on hardware that evolved for an entirely different purpose. The hardware says, avoid pathogens. The software says, insects are pathogens. And the software is wrong. Demonstrably, measurably, nutritionally wrong. So who wrote that software and why? The answer starts in the Neolithic period, roughly 10 to 12,000 years ago, when communities across the Fertile Crescent, the Yangtze River Basin, and Mesoamerica independently began domesticating plants and animals. In tropical and subtropical regions, where insect biodiversity is extraordinary, and many species are available in enormous quantities nearly year-round, insect harvesting remained practical and productive even as farming developed. A household in central Mexico could grow maize and squash, while simultaneously gathering grasshoppers, agave worms, and ant larvae from the surrounding hillsides. The two systems ran in parallel, each reinforcing the other. But in the cooler, more seasonal climates of northern Europe, the math was different. Insect populations in temperate zones are smaller-bodied, less diverse, and simply absent for large stretches of the year. The winters are long. The species that do survive tend to be scattered thinly across wide areas, making them far less efficient to harvest at scale than managing cattle. Sheep, goats, and pigs, animals that survive winter, provide milk and wool and labor on top of meat, and convert Europe's vast grasslands into usable calories with a consistency that seasonal insect foraging simply could not match. Anthropologist Marvin Harris at Columbia University made exactly this argument in his 1985 book, Good to Eat. Harris applied a framework called cultural materialism, which holds that food preferences aren't arbitrary. They're shaped by ecological constraints and the practical options available in a given environment. In his analysis, temperate European cultures didn't stop eating insects because they collectively discovered insects were disgusting. They stopped because livestock offered a more reliable year-round protein source in their specific climate. Over generations, the practice simply faded out of the cultural repertoire. The disgust came later. It was a rationalization built after the fact, a story constructed to explain and reinforce a habit that had already changed for purely practical reasons. And once that story took hold, it hardened into identity. Civilized people raised livestock and ate meat and dairy. Eating insects became associated with poverty, with the wilderness, with a way of life that agriculture had supposedly left behind. The distinction was never really about nutrition. It was about status. This might have stayed a minor regional quirk, one farming culture in one climate zone making a locally sensible choice. But European food culture did not stay in Europe. It was carried outward on the ships of colonial expansion, and it was imposed on civilizations that had maintained sophisticated, thriving insect food systems for thousands of years. When European powers arrived in Africa, Asia, the Americas, and Oceania beginning in the 15th century, they encountered peoples for whom insect consumption was normal, nutritionally essential, and often deeply significant culturally. The Aztecs harvested the eggs of aquatic insects from the surface of Lake Texcoco, a delicacy so prized it was served at royal banquets and later described by some as a kind of Mexican caviar, gathered using techniques refined across generations for sustainable long-term harvest. Around the Great Lakes of Central Africa, communities in what is now Uganda, Tanzania, and the Democratic Republic of Congo built parts of their seasonal calendar around the emergence of lakefly swarms, billions of tiny insects rising off the surface of Lake Victoria in clouds visible for miles. Villagers collected them with dampened baskets and pressed them into dense protein cakes that could be dried and stored for months, with protein density that outstrips beef by a wide margin. In Aboriginal Australian communities, the witchetty grub, the larva of a moth species found in the roots of certain desert shrubs, was one of the most complete single foods available in one of the harshest environments on the planet. A single large grub delivers roughly the calories of a candy bar, but with a far superior fat and protein profile, and it was gathered with ecological knowledge passed down across tens of thousands of years, not eaten out of desperation. None of these were primitive practices. They were locally adapted, sustainable, and often more efficient than the systems that replaced them. But colonizers didn't see sophisticated food technology. They saw people eating bugs, and within their own cultural hierarchy, that placed those communities at the bottom of an imagined ladder of civilization. Missionaries discouraged insect eating as part of broader campaigns to replace local customs with European ones. Colonial administrations promoted European-style livestock farming as a marker of progress, redirecting resources toward cash crops and imported cattle breeds poorly suited to tropical climates and thirsty for water and land. The damage outlasted the colonial governments by generations. In many former colonies, insect foods that had been openly eaten and celebrated for centuries became quietly associated with poverty and backwardness. Young people in rapidly urbanizing cities began turning away from the foods their grandparents ate, not because the food had changed, but because its cultural meaning had been deliberately rewritten. Colonialism didn't just extract resources, it extracted food identity and replaced it with a hierarchy that put European habits at the top and everything else beneath. If the story stopped there, it would already be worth telling. But there's a paradox buried inside Western food culture so glaring it should have collapsed the whole disgust narrative decades ago. And somehow, it never has. A lobster is an arthropod. So is a shrimp. So is a crab. Taxonomically, crustaceans and insects both belong to the same broad phylum, sharing a common ancestor, a segmented exoskeleton-bearing invertebrate that lived in ancient seas hundreds of millions of years ago. A shrimp and a grasshopper share jointed legs, compound eyes, exoskeletons made of chitin, and segmented body plans. In evolutionary terms, a shrimp is more closely related to a cricket than either one is to a salmon. And yet a plate of garlic butter shrimp in a Manhattan restaurant costs $30 and carries an aura of sophistication. A plate of garlic butter crickets at the same table would clear the room. The inconsistency runs deeper once you look at the history of foods now sitting comfortably atop Western cuisine. Lobster was not always a luxury. In colonial New England, it was food fit for the poor and for prisoners, so abundant that some accounts describe indentured servant contracts limiting how often employers could feed it to them. It took roughly 2 centuries of marketing, rail distribution, deliberate supply restriction, and cultural repositioning to turn it into a symbol of fine dining. The animal never changed. The story about it did. Sushi tells a version of the same story, compressed into a single generation. Raw fish struck most of the Western world as strange, even mildly repulsive, well into the 1970s. Diners who happily ordered steak tartare recoiled at raw tuna. Within about 30 years, sushi became one of the most popular dining categories across North America and Europe. The biology of raw fish never changed. The narrative around it did. That single fact, that disgust is a story, not a fixed biological truth, is the whole argument for why insect protein could still have a future in the West. But so far, the biggest modern effort to bring insects into Western diets has largely stumbled. And the reason why is instructive. That 2013 FAO report from Arnold van Hoos's team landed like a shockwave in food science circles. Nearly 200 pages of data, and the conclusion was unambiguous. Insects represent a viable, underused resource capable of addressing global protein security, cutting environmental damage, and creating economic opportunity in developing and industrialized nations alike. This wasn't framed as an exotic curiosity. It was framed as a strategic necessity for a planet heading toward 10 billion people. The response came fast. Between roughly 2013 and 2016, a wave of insect protein startups launched across North America and Western Europe. Companies began producing cricket protein bars marketed toward fitness-conscious consumers. One insect food company became the first of its kind to appear on a major television investing show, securing funding and national attention. A commercial cricket farming operation launched in Texas, backed in part by prize funding tied to a former U.S. president's foundation. In the Netherlands, a black soldier fly farming company raised hundreds of millions of euros aimed at both human food and animal feed markets. On paper, the market was enormous, the protein data superior, the environmental case unanswerable. Venture capital flowed in. The revolution was supposed to arrive on schedule. It didn't. What these companies discovered, the hard way, is something the FAO report had acknowledged in careful academic language, but couldn't solve with data alone. None of it matters if the consumer won't put the product in their mouth. Across consumer testing in Western markets, the same pattern repeated. The barrier wasn't taste, price, or availability. It was disgust. Consumers who said they'd be willing to try insect food in surveys frequently couldn't follow through when an actual product sat in front of them. The marketing response was revealing. Nearly every Western insect protein company converged on the same strategy: hide the insects. Cricket flour was milled fine enough to be visually indistinguishable from wheat flour. Protein bars were coated in chocolate, packaged with branding that evoked gyms and wellness rather than entomology. Pasta was made with mealworm flour blended into semolina at ratios too low to detect on the palate. The entire commercial strategy became an exercise in making the core ingredient invisible. Billions of dollars went into companies whose central innovation was disguising their own product. The consumer won't accept it as it is, so the industry's answer is to hide it inside something else and hope nobody notices. Compare that to the economies that never went through a cultural rupture. In Thailand, the edible insect market generates hundreds of millions of dollars in annual revenue. Street vendors across Bangkok and the rural northeast sell fried grasshoppers, bamboo worm larvae, silkworm pupae, and giant water bugs from open carts, visible and eaten in public with the same casual normalcy as a bag of chips. Thailand has registered tens of thousands of licensed cricket farms. Nobody is hiding the crop, because there was never a break in the tradition to begin with. In Oaxaca, Mexico, chapulines, grasshoppers seasoned with garlic, lime, and chili are sold by the kilogram, served in tacos and scattered over tlayudas, in a tradition stretching back through the pre-Columbian food cultures of the Zapotec and Mixtec peoples. Escamoles, ant larvae harvested from agave and maguey roots, are a seasonal delicacy commanding prices comparable to premium seafood. Sometimes called insect caviar, served at restaurants that draw tourists worldwide. The food is celebrated, not concealed. In the Democratic Republic of Congo, caterpillars are among the most widely traded non-timber forest products in the country, with dozens of species regularly consumed and harvest volumes running into the tens of thousands of metric tons annually. Dried caterpillars sit on Kinshasa market shelves next to smoked fish and dried beans as an ordinary grocery item. Across southern Africa, the mopane worm supports an industry worth tens of millions of dollars. Sun-dried and traded across borders, a critical source of nutrition and income requiring no feed, irrigation, or land conversion at all. The worms eat the leaves of the mopane tree. People eat the worms. The system has run sustainably for as long as anyone has documented it. These are not marginal, fading practices. They are active, economically significant food systems serving billions of people right now. The global edible insect market was valued at roughly $1.5 billion in the early 2020s, and industry projections put it well above $9 billion within the decade. The growth is real, but it's happening almost entirely outside the Western consumer market, in places where the cultural break never occurred. The regulatory environment hasn't helped close that gap. In the European Union, edible insects were folded into the Novel Food Regulation in 2015, a framework requiring any food without a significant history of consumption in the EU before 1997 to undergo extensive safety review before it can legally be sold. The process is slow and expensive. By the early 2020s, the EU had approved only a small handful of insect species for human consumption, including the yellow mealworm, the migratory locust, and the house cricket, each requiring years of review and substantial documentation. In the United States, the picture is murkier still. There's no explicit prohibition on selling insects for human consumption, but no clear, dedicated regulatory framework either. So producers navigate food safety standards designed for conventional livestock that don't always translate cleanly. Allergen labeling is a genuine concern. Chitin, the main structural compound in insect exoskeletons, is chemically related to compounds in crustacean shells, meaning people with shellfish allergies may react to insect protein, and the cross-reactivity isn't fully mapped. The result is regulatory uncertainty that raises costs and scares off investment. And here's the regulatory system's quiet absurdity. The same food safety system that lacks a clear pathway for deliberately farmed, hygienically produced insects maintains official documents establishing the maximum allowable levels of unavoidable insect contamination in ordinary food. Peanut butter, wheat flour, ground spices, canned goods, and frozen vegetables all carry their own thresholds. You are already eating insects. You have been your entire life. Nobody told you, because the quantities are treated as incidental rather than nutritional, and those insects were never farmed, washed, or processed under any safety standard whatsoever. They're contaminants, allowed contaminants, and you consume them without knowledge and without disgust. A cricket raised deliberately on certified feed in a climate-controlled facility, tested for pathogens before sale, faces more regulatory scrutiny than the fragments arriving unannounced in your flour and your spice rack. The system was never built to protect you from insects. It protects you from knowing about them. There's one more piece to this, and it might be the piece that decides whether any of this actually matters on a civilizational timescale. Global population projections put us at somewhere close to 10 billion people by 2050, an increase of roughly 2 billion within a single generation. Feeding that population at current dietary standards, which are already inadequate for the hundreds of millions of people experiencing chronic hunger today, will require a substantial increase in total food production. Conventional livestock agriculture cannot deliver that increase without consequences already visible in satellite imagery, water tables, and atmospheric readings. Animal agriculture already occupies the majority of the planet's agricultural land, while producing a comparatively small share of total calories and protein. Cattle ranching is one of the largest drivers of deforestation in the Amazon, with land cleared at a staggering pace, primarily for grazing and for growing soy destined for animal feed. Freshwater scarcity is accelerating alongside rising demand. Agriculture consumes the overwhelming majority of global freshwater withdrawals, and livestock production takes a disproportionate share of that. The thousands of liters of water needed to produce a single kilogram of beef aren't just an abstract statistic. In a water-stressed region, that same volume could meet a household's needs for months. The demand curve for protein is rising steeply, driven by population growth and by the dietary shift happening across rapidly developing economies, where rising incomes reliably bring increased meat consumption. The supply side of conventional livestock agriculture is approaching, or has already exceeded, the ecological limits of available land, water, and carbon budget. Something has to give, whether or not anyone makes a deliberate choice about it. Plant-based proteins and lab-grown meat have both attracted serious investment and attention as alternatives, and both have real merit. But neither matches the combination insects offer. Nutritional density, production efficiency, minimal infrastructure requirements, and scalability. Plant proteins often need heavy processing to hit a complete amino acid profile. Cultured meat remains expensive and energy-intensive to produce at any real scale. Insects can be farmed with minimal capital in almost any climate, on feed that would otherwise go to waste, by communities that already hold generations of accumulated expertise in doing exactly that. The ancestral protein source, the one that carried the primate lineage through millions of years of climate shifts, forest contraction, and population bottlenecks, is sitting on the table right now. It's nutritionally validated by every relevant scientific body that has studied it. It's environmentally superior by essentially every measurable standard. It's economically viable, proven every single day by the thriving insect economies of Southeast Asia, Latin America, and sub-Saharan Africa. And it is being blocked, in the wealthiest and most resource-hungry nations on Earth, by a culturally constructed emotional response that a 2-year-old hasn't learned to feel yet. The evolutionary machinery built to process insect protein is still inside you. The enzymes are there. The digestive pathways are there. That metabolic architecture, shaped across millions of years of entomophagy, hasn't degraded because evolution moves slowly, and the handful of centuries since parts of Europe abandoned insect eating amount to less than a blink on the timescale of human biology. Your body doesn't know your culture decided insects were disgusting. It still processes them exactly the way it always has. So the real question was never whether insects are the most efficient protein available. The data settled that a long time ago. It isn't whether humans can actually eat them. 2 billion people are answering that question at dinner tonight. It isn't even whether the Western disgust response can be undone. Lobster and sushi, and 100 other foods that migrated from revulsion to prestige, prove that food preferences aren't fixed features of human psychology. They're stories, and stories can be rewritten. The real question is whether the rewriting happens fast enough, because the planet isn't waiting for a cultural consensus. The carbon keeps accumulating, the aquifers keep dropping, the forests keep burning, the protein gap keeps widening. And a meaningful part of the answer has been sitting in plain sight the entire time. A food so ancient, so efficient, and so thoroughly proven that most species on Earth never stopped eating it. Your ancestors shaped bone tools to get at it. Your closest living relatives still fashion twigs to harvest it every single morning. 2 billion of your fellow humans will eat it for dinner tonight. The only thing standing between the wealthiest civilizations on Earth and the most efficient protein on the planet is a story someone told you when you were 5 years old about what good people eat and what they don't. That story was never built on evidence. The evidence has pointed the other way the entire time. And the clock isn't interested in how the story makes you feel.